Hello students. So today we are going to learn the last of that chapter, that is the motion in a plane. So we were talking about projectile motion. So first we have talked about vectors. Why? Because sometime we need to split our vectors in order to make our problem very simple, and here we will use this thing like the concept of components of vector, okay, to solve those projectile motion. So in the last video I have told you a little bit about it, what is projectile motion. Any motion that represent motion regarding your height and your distance. So let us imagine that from the position O, I am releasing some missile in a direction of this, in a direction like this, and the missile, so my direction of throw is like this, and the missile is going like this, reaching this point and coming at this P point. So if I say the total horizontal distance is r, and this is the range of my missile, and this maximum height achieved or the vertical displacement by the missile is h. So in that case you can say that this motion is happening in a two-dimensional frame. Why two-dimensional? Because there r is involved as well as your h is also involved. So you can define two axes, one is your x and another one is your y axis. So what we will do basically, if say I have projected the missile with an angle theta with my horizontal x axis with a velocity v, because I will be knowing the actual velocity, right? So this velocity is a vector, so I'm giving a v vector sign, but though we will not be thinking so much about it, because anyway we are going to split the vector, so we will take only our values of components. So the portion of v vector that is working in x axis, if I just project the vector in x axis, so this one will be my v cos theta, and if I project in y axis, so the portion of velocity that is working in y axis will be my v sin theta, right? So v cos theta is merely the value of v, and you may ask, so why you are not giving now the vector sign? Because I am taking only the value, and the direction already it is applied in terms of theta. So cos theta is representing the direction, like a directional contribution. So in that case, now our this motion which is happening in your horizontal and vertical horizontal and vertical like portions. So basically you can say this is the motion in a plane. So whenever the motion is involved in two-dimensional frame of reference, then you can say that the motion is in a plane, right? So what we will do now, we will use our old those three equations of motion, because this two-dimensional motion I have now split it into two one-dimensional motions. One of them is the v cos theta, which is acting to make the missile move in horizontal x-axis, and another one is your vertical component, that is v sine theta, which is responsible to move it in the vertical component, that is y component. So basically from 2 dimension we are now reducing the problem in 2 one-dimensional problems. So one by one we will solve them. So coming to the first one, you can see, so I'm just writing here 2 things. The first one is your so I'm not writing horizontal or vertical, instead I'm writing x-axis and y-axis, so that you can understand which one is your vertical, which one is your horizontal motion. So let me talk about first the horizontal motion. You know that the missile is going up till this point and it is coming down again. Why? Because so that means something is pulling it downward. So downward we know that only gravity is working. So in the vertical motion we have acceleration g, which existed, right? So the vertical motion is involving the gravitational acceleration g. So when the missile is going upward till this point, the velocity, that is v sine theta, is slowly decreasing, right? And it is becoming 0 at the topmost point, and again due to g it is coming back, and at this point whatever was the velocity at the initial point, this point the velocity is same. Now this we can prove, and this we will prove later on, but this is the scenario. But in x-axis if you see, there is no acceleration. Now you can ask me why there is no acceleration. See, when the missile is thrown, let us imagine that the missile is not self-propulsion, is not using a self-propulsion engine. Okay, that means I have just given some force at the time of launch, and then there is no force. That means it's a contact force. So whenever I am applying a contact force, once the missile is detached from my launch pad, there is no force acting on the missile, like in horizon, due to launch. Okay, so that means only g will work in the vertical way, but there is no other acceleration in the horizontal way. Now one more thing, we are neglecting the air resistance, because we know that due to air resistance the velocity in the horizontal component may also decrease, but we are neglecting that. So it is very negligible, because missiles are having generally aerodynamic shapes. So what is the thing that this v cos theta is the initial horizontal velocity, right? So when the missile is launched, that time the total velocity was my v, right? So v was my total velocity, but so if I split the v, so I can see the initial velocity was v cos theta for horizontal axis and v sin theta for your vertical axis. So this v cos theta is responsible to move the missile in x-axis, that means for the displacement r, that is called range, and v sin theta is responsible only to raise the distance, that is your h, that means it is responsible for the vertical one. So that means you can see that if there is no other acceleration in x-axis, so this v cos theta will not change. That means at the point of your initial launch and the whole time, and also the point of your just reaching and impact, this this component, that is your x component of velocity, will be always constant. Okay, so now we can here like equate two different motions. So talking about the range, that is this r, we can use the simple formula, that is s equal to vt, because here no acceleration is involved. So we can write r equal to v into time. So we are assuming that the total time taken by this missile to impact is t, big T. So we can always write our r is equal to our velocity. Now which part we will use? Only v cos theta we will use, because v cos theta is responsible for the displacement r. So that is my v cos theta into big T. Now I don't know T, right? So you think one fact that what is like, why the missile is stopping at P? Because if v cos theta is not decreasing, so the missile should go for like indefinite time. But why it is stopping at P? So you can immediately understand that it is going up and it is going down. So when it is touching the ground, it is stopping there. So that means the time of impact depends on your vertical one, that is your vertical motion. So this time t we will get from our vertical motion. So let us talk about vertical motion. So we will use what we will use now. Let us see. We will use v equal to u plus at. So in that case, it is deceleration when it is going from position O to position. Okay, so I am defining some more position. Let us say this is my position R. To go from position O to R, let us say it is taking a time small t. So in that case, we can always write that this displacement h. Okay, let us first write this one, v, that is my final velocity. Now you tell me what is the final velocity when the missile is at r. So see, once the missile is at r, it is not going further up, but it is going down. That means at that point r, all the velocity like all the vertical velocity component is exhausted because of the deceleration. That means my final velocity is 0. So instead of v equal to u minus gt, I can write the final velocity v is equal to 0. So I am writing here 0. Now what is my u? U means the initial vertical velocity that with what it was launched for its vertical motion. So that is my v sine theta. So I will use v sine theta instead of u. So instead of u, I will use v sine theta. And now I have my minus gt. So from here I can find out the time. So my time is v sine theta by g, right? G. One more time you can see that when it is coming from r to point P, the initial velocity is 0 and now it is acceleration, and my final velocity at P I can find out that is also v sine theta. So I can find out that. Okay, so how to find out that? We will come back slowly. Okay, so but for now you take for granted that the time to get from O to R is same as the time from going down from R to P. So in that case we can tell that the total time for reaching O to P is 2 into that time. So it is 2v sine theta by g, because the time for reaching O to R and the time for reaching R to P are the same. So this is t equal to 2v sine theta by g. So I can put the t here. So I can easily write that it is v cos theta into 2v sine theta by g. So I will get here v square sine 2 theta. Why sine 2 theta? Because your 2 sine theta and cos theta is your sine 2 theta. I think you know this, and if you don't know this, please see once your trigonometry part. So basically this is your range r. That means the highest distance or the displacement made by the projectile, right? So this is one of my findings. Now coming to the next one, that is my height, how much it has gone. So let us use this formula, s equal to ut plus half at square. Is equal to ut plus half at square, right? One more formula I have, that is my s equal to my v square equal to u square plus 2gh. Now in this case, while going up, you know that it is the acceleration. So my final velocity is 0 and my initial velocity is v sine theta. So if I use here for this formula, let us use at first. So I can use here my final velocity is 0, my initial velocity is v square sine square theta minus 2gh. So I can see that my h equal to v square sine square theta by 2g. So this is my another finding. So I have seen that the height gained by the projectile is given by this formula. Okay, if I use this thing, so instead of s, I can write here h. I know my my final velocity. So while going up, let's say, so my initial velocity is v sine theta and my time is t, let's say. So my at square also I can use here. So while going up, it is minus, so it is g by 2 t square. So instead of t, we can use this formula that is already gotten, that is my this one. So I can use this formula. So if I use this formula, so I have to write here v sine theta by g. So instead of t, I am writing here v sine theta by g, and here also I can write v square sine square theta by g. So you can see one thing clearly, again this h will come similarly, that is v square sine square theta by 2g. So you can see in both ways you can find these values. Now talking about this one, I told you the time for gaining O to R and the time for descending R to P are the same. So let us find this one. So one thing is very clear, that is so I have to find out actually that from R to P what is my vertical movement, right? What is my vertical motion? So when it is coming from R to P, the initial velocity is 0, right? So but I have to find the final velocity. I want to see whether the velocities are same or not. So what I will do here, I know my h, right? So I will use this formula, h equal to, let us try, okay? Let me assume that I also don't know how to do this. So h is equal to ut plus half at square. So in that case, I know that ut plus half at square or gt square. So during descent, or coming from R to P. Okay, so that you can understand. So what is basically we're talking about? R to P. So we can see that my h equal to ut is 0 because initial velocity is 0, half g t square. So my t square, t is your 2g by h, right? Now height already I know. What is the formula for height? The formula for height is v square sine square theta by 2g. So let us use this. So we can find here 2 into v square sine square theta by 2g, and one more g was there, so it will become g square. So it's gone, and I got v sine theta by g. You can now see it is easily that the time what we have at first gained, that is t equal to v sine theta by g, for the missile to go from O to R is the same as the time for the missile to go from R to P. So if the t is same, so final velocity also you can find out very easily using our that formula only, that is v square equal to u square plus 2fs. Now v square equal to u square plus 2gh, here it will be plus because it is acceleration when coming down. So my initial velocity, that is u, is 0 in this case because it is coming from left, and then so I can write here 2g. Now h, again I can write this formula, that is my v square sine square theta by 2g. So if I use here v square sine square theta by 2g, I can see that 2g gone. This final velocity v, this is not that velocity, okay, I'm just talking about the final velocity. Let us give one name. So it is vf, let's say. So my vf is v sine theta. So you can see that the velocity with what it was launched, that is the initial vertical velocity, that is v sine theta, is same when it is coming down and just before the impact at P. So the final velocity while coming up, like while going up and then just after touching the ground, is same. So this one and this one is the same. Okay, so it is general in all the cases. Like if you throw a ball, so with what velocity you are throwing the ball, when it is just coming down and just it is about to touch your hand again, it should have the same velocity. But because of air resistance, the velocity can decrease, but in ideal situations it should be same. So basically we have seen that the main objective, that is to find the range, because whenever you are launching the missile, you should know where you are, what is your target, right? It is like your own home or it is someone else's home. So whenever you are throwing some a garbage or a piece of paper or a ball of paper into your garbage bag or your dustbin, you should know how much it should, you have to calculate by your mind, right? So our mind just don't calculate like this, but we get some estimation. So basically this is it. So what are our findings? Our findings are these. First finding is this one, that is our range. Our second findings is the total time taken, and the individual time also we have found out. Then the next one is our height, that we can find out by two methods, anyone you can use. And so basically so you can ask me, sir, why from this +2? So that we don't have any confusion, I'm just writing, because I wrote this so that you can remember the form, that's it. So this, and we have seen that the time taken so to go up and to go down are the same. That's it. So in the next, like, so this was all about your this what you say, projectile motion, but so many maths we have to do. So this kind of math you can do. The math is like, if I am throwing a ball from a height h, so ball will go like this, right? So try to find out r in this case. If you are throwing a ball like this, so with a velocity, let's say v, so trying to find out r in terms of v as a function of v. Okay, so trying to find out that this kind of math is very useful for us. Also try to find out your t time, like you assume t. Okay, you assume t, otherwise it is not possible for you to find it out like that easily. But okay, you assume first t and then you find out also some expression for t as well. Okay, so for today this much is the class, and in the next topic we will start about, like, for energy and the motion of, like, Newton's law of motions. Those are also a little bit interesting, and we will also use the vector concept in a very nice way. You can see here also you have used the vector concept, which is very interesting also. Like, how do you see this there? Here we have used the resolution of vector, that means to split the vector into its component, right? So with this the motion in a plane, I think, is completed. This one, that is vector, and this if we have to do numericals actually, but the basic is almost like this. Okay, so see you in the next class. Till then, please watch this video and, what to say, try to do that math.